Welcome to another ALEKS Geometry Topic instructional video by Mr. Hardy. What we're going to look at with this video is finding the area of a rhombus. So a rhombus is a sort of a special parallelogram. So before I go into the information on how to do this, what I'm going to do is let's look at the background information. So whenever they tell you that it's a rhombus, what it is it's a parallelogram. And this isn't kind of hard to draw, but the sides, a parallelogram with the sides are congruent, so the sides are the same. So that means that these two sides are parallel and these two sides are parallel. They have the same slope. In addition, they're all the same length. The sides are all the same. So if this is 4, then this is 4, and this is 4, and this is 4. Doesn't mean it's a square unless the angles are 90 degrees. Then it would be a square. Okay, so that's something that we might be able to take advantage of. The other thing that it says is diagonals. So this is a diagonal that cuts across like that from one corner to the other. That's called a diagonal. And the other diagonal, when they cut across, they bisect. What that means is that they hit the midpoint of the two lines. So if this whole thing was 8, then this would be 4, and that would be 4. And if this whole thing was 3, then this would be 3, and that would be 3. So that's some information that we could take advantage of. Okay? So here's what we can do. We can see that this distance right here is 30 from all the way across. I don't even know if I want to draw it like that. So that means this is 15 and this is 15. And this distance from here to here is 18. From Q to S is 18. So this is 9 and this is 9. Alright, so what I can do is I can find the area. There's two ways. I could find the area of just this triangle and multiply it by 4 because there's 4 of them. Or what I could do is find the area of this big triangle right here. I think that's what they do in ALEKS. So it would be, so the area of a triangle is 1/2 the height times the base. So 1/2, if we call this the base right here, that's 30. And then the height, oh, I did it the other way around, didn't I? So I put the base in first. Let me change that. The height times the base. The base is, the way I'm drawing it, this would be the base. And then the height is 9. Okay? And so what would that give us? I can do half. Well, I'll just do it on the calculator. Half of 30 is 15. But let's just do this. Let's just do 9 times 30. And then we divide by 2. Actually, okay, so it's 135. But that's just the area of this side. So we still need to double it because this triangle here on the other side is the same. So the area for the total area would be 2 times 135. And so that's back to 270, right? That's kind of where we came from. So times 2 equals, wait, clear, 135 times 2, 270. Okay, so there is another method that sometimes works. It says 1/2 times the diagonal of one diagonal times the length of the other diagonal. So in other words, area equals 1/2 D1 times D2. So if you want to use this, if Sometimes they don't give us the diagonal, but here they did. They said it's 30, right? So it's 1/2 of 30 times the diagonal of 18. So they gave us both diagonals, so we can plug them in. So half of 30 is 15, so 15 times 18 should be the same. 15 times 18 equals 270, okay? So 270, and what are the distances? Meters, so it's meters squared. Meters squared. Okay, so knowing you only need to use one method. The formula might have worked easier for this method, but you should know both. I want to take a look at one more if you've got time, because here they do something I think a little bit differently. Here's a rhombus, as you can see, and they say from E to D. So from E to D, so they're not giving us the diagonal this time. They're just giving us that amount. And from F to D, F to D is 7. Okay, so what we could do, if you look at this triangle, if I put it up like this, that's not very good. Try it again. If I kind of rotate it like that, 7 and 10, for this triangle, we can say that the area equals 1/2 the base times the height, or the height times the base, doesn't matter. I'm going to do it that way. So half of 10 is 5. Okay, so 5 times 7 is 35. Okay, so I found that the area for this triangle here is 35. But there's 4 of them. 1, 2, 3, 4. So the area for the total would have to be 4 times 35. Okay, so 4 times 35. 4 times 5 is 20. 4 times 3 is 12, plus 2 is 40. So I get 140. 140 millimeters squared. Okay, so in this case, the formula that A equals 1/2 the base 1 times base 2, you could do that, but you would have to say, oh, they gave me 10, so the diagonal all the way across, did I say base? I meant diagonal. The diagonal all the way across would be 20. And then the diagonal this way would be 7 plus 7 would be 14. Okay, so you could still use the formula. So half of 20 is 10. 10 times 14 is 140 millimeters squared. So it works, but you would have to know to double it. Okay, so there's a lot of different ways of doing this. Give it a try. If you have questions, make sure you ask. Good luck.